A sealed pipe system has regions with high fluid velocity and low pressure. What principle explains this inverse relationship? And they say Pascal's law, Bernoulli's principle, Archimedes' principle, and Raynaud's number. Okay. Well, the correct answer here is actually going to be B, but let's talk about why that is. Okay, so first of all, let's imagine we have a pipe, kind of like in the previous question, where maybe it narrows at a certain point. Okay, and we're going to have some volume of fluid flowing in this pipe. Here it's going to flow with a velocity 1, and here it will flow with a velocity 2. And at each of these points, there's a pressure exerted by that fluid on the wall of its container, P1 and P2. Now, we're also going to assume that the height of both points, of both areas here is the same. So height 1 and height 2 are the same, okay? So like the pipe doesn't change in height. The fluid is flowing along the same, at the same height, okay, in both cases. So Bernoulli's equation, which we can use to explain why this is the case, is as follows. And this is assuming that there's no non-conservative forces, like no friction, right? Which what we're going to say is that the pressure at point 1 plus 1/2 the fluid density multiplied by the velocity of the fluid at point 1 squared, okay? Plus then also the density multiplied by the acceleration due to gravity multiplied by the height of point 1. And all of that is conserved. This is saying that this is conserved throughout, right? And so it's going to be equal to the pressure at point 2 plus 1/2 v2 squared, so the velocity at point 2 plus the density, which is the same, of course, multiplied by g, which is the same, multiplied by height 2. Now, we specifically made the assumption that these two are the same, so these will cancel out. So we get the simplified version, which is that the pressure at point 1 plus 1/2 mu v1 squared is equal to the pressure at point 2 plus 1/2 mu v2 squared. Okay, and so this explains to us why the phenomenon, or the phenomenon that they're talking about. So basically, if the fluid is flowing faster, like here, of course, it'll be flowing faster because it's a narrow point of the pipe, right? Then the pressure on the wall of the container P2 there, okay, has to be lower. So if V2 is greater than V1, then P2 has to be less than V1. And you can conceptualize this by thinking about it like if the fluid is flowing very fast, it has sort of less time to push on the wall of the container, right? It's moving really fast. But if it's moving slower, there's more pressure exerted on the wall. It has more time, okay? So that's the inverse relationship, and Bernoulli's principle is what explains that.